If you need help with Pythagoras, then stick with me while I go through some key questions and a little extension where you may need that help. Very important for your maths GCSE, both foundation and higher. So Pythagoras' theorem. Well, it's a theorem that is used in order to calculate the missing side of a right-angled triangle. So if you're given two sides, it's to find the third, but it only works in right-angled triangles. And the theorem is this: it's that a squared plus b squared is equal to c squared. Well, I'm just going to start by going through how we would label our triangle to start with. This c squared is really, really important. It is the hypotenuse of the right angle triangle. So you have to specifically put that on the side of the longest side of the right angle triangle. And the longest side is always the one that is opposite the right angle. So that has to have the label C. A and B are effectively the shorter sides, okay? So A and B are the shorter sides, and it doesn't matter the order in which you put those. So A and B, I'm going to label them A and B. And the theorem is this, that if we square the two shorter sides and add them together, it's equal to the hypotenuse squared. So let's give some values of 3 centimetres for A and 4 centimetres for B. Now the theorem states that if we square A, now that means we're doing 3 times 3. So let's say it's the area of this box here. So that would be 9 centimetres squared. Then we square 4. Well, 4 squared is 16. So that gives us 16 centimetres squared. It would be equal to the hypotenuse squared. Now 9 plus 16 is 25. So in order to create a box that is 25 centimetres squared, the side length of C would be 5 centimetres. And that is how we use Pythagoras to find out the missing length. But I'm going to show you a more formal way of doing that. But what we're saying is that the area of this box and this box would combine together to make the area of the longest side squared, okay? So writing this out formally, we would write this. A squared, we knew A was 3, so we would write 3 squared. B squared, we knew B was 4, so we would write 4 squared, equals, well, C squared, imagine we're trying to find C squared. That's 9 plus 16 is equal to C squared, 25 is equal to C squared. So in order to find C, we would have to square root the 25, which gives us 5 centimetres. Okay, let's move on then through some questions. So trying to find the hypotenuse again, that's our C, the longest side. A and B, the two shorter sides, can be in any order. So we know that A squared plus B squared is equal to C squared. 5 squared plus 7 squared is equal to C squared. 5 squared is 25. We're adding it to 49 to give us C squared. So in total, that's 74. Is C squared. So C would be the square root of the 74. And the square root of 74 is equal to 8.6. There we go. Okay, so that works when we're finding the hypotenuse. We're squaring the sides, adding them together, and then square rooting. So square, add them together, and square root your answer. There's those 3 steps. When we're finding a shorter side though, it's a little bit different. If I go back to this diagram, if these two are adding together to make the 25 squared, then it would work to do 25, subtract the 16. If we were trying to find the other missing side would be 9, wouldn't it? So if we're trying to find a shorter side, we actually subtract the values from each other. So A squared plus B squared is equal to C squared. But if you're trying to find A, for example, then A squared is equal to C squared, subtract B squared. Okay, so let's put that into the formula. C squared is 8 squared. And we're subtracting 5 squared, which is 64 subtract 25, which is 39. So A squared is 39. A is going to be the square root of the 39, which is equal to 6.2 to 1 decimal place. So that's 6.2 centimetres because it's a length. So if we are finding the longer side, the hypotenuse, we add, but then I remember this, the shorter side, one of the shorter sides, we're going to subtract those values from each other. Don't forget that we are subtracting them, okay? And then we get on to something like this. So we are trying to find x. Therefore, we need to use this right angle triangle. However, we're only given one side. We need two sides to find the third side when it comes to Pythagoras. Therefore, first I need to work out what this side is going to be. And I do that using, let's call it right angle triangle number 1. Okay, so just considering right angle triangle number 1, we have the hypotenuse, we're giving that the value c, we have a and we have b. Now as we're trying to find a shorter side, we're going to subtract them. A squared plus b squared is equal to c squared, but we're trying to find a, so a squared is equal to c squared, subtract b squared. C squared is 7 squared and b squared is 6 squared. 49 subtract 36 is equal to 13. So a squared is 13. A is equal to the square root of 13, which is equal to 3.6. Now, for the purpose of this question, I'm going to leave it as the square root of 13, because if I put that into my calculator, I'm going to get a long decimal here that if I round it, I'm just making it more inaccurate as I go along in the rest of the question. So I need to keep the full answer for as long as possible. So we're keeping it as square root 13. Now, if we're now trying to find this x, then I'm calling that c. We then have a and b. A squared plus b squared is equal to c squared. So we're adding them. We need to do the root 13 squared added to 4 squared is equal to c squared. Now, square root of 13 squared, please feel free to put this into your calculator, but it is just going to give us the number 13. We're basically squaring a square root sign, so it undoes it. They cancel each other out, gives us the number 13. So we have 13 plus 16 is equal to c squared. 29 is equal to c squared. And if we square root the 29, it gives us 5.39 to 2 decimal places. And that length is in centimetres. Okay, so there's a trickier Pythagoras question. Hope that's helped. Subscribe if it's been useful, and we'll see you in the next video.